Assalamualaikum and hi everyone. My name is Hanie FAREYSHA binti HASSAN. In this video, I will present for question 1, Roman 1, which is explain vertical loads and lateral loads as types of loads imposed on the frame and the structure. What is load? A load is a force that a building or structure needs to be able to resist. Loads causes stresses and deformation to a structure. The structure or part of the structure does not fail when these loads are applied vertically or laterally on a structure. Determining the total load acting on a structure is very important and complex. There are two types of loads, 1. Vertical loads and 2. Lateral loads. Vertical loads or gravity loads are those forces that are applied perpendicular to the roof or floor system. They separated into 3 categories. 1. Dead loads, 2. Lift loads, and 3. Snow loads. Firstly, dead loads are the static loads that result from the weight of the building itself and its permanent components. This includes the weight of the wooden framing, floors, walls, roof, and any fixed equipment. The specific weight of the wood used and the building's design will determine these loads. Secondly, lift loads are dynamic loads that result from occupants, furniture, appliances, and other temporary items within the houses. These loads can vary and need to be considered in the design to ensure that structure can safely support the people and items inside. Lastly, snow loads. Depending on the geographical location of structure, one may need to consider snow loads. The amount of snowfall in the region and the weight of accumulated snow on the roof can impact the structural design. Roof design and pitch are important factors in managing snow loads. Secondly, lateral loads are lift loads that are applied parallel to the ground. That is, they horizontal forces acting on a structure. They are different to gravity loads, for example, which are vertical and downward forces. They separated into 2 categories. 1. Wind loads, 2. Seismic loads. Firstly, wind loads are especially important in areas prone to strong winds or hurricanes. The design should account for the wind forces that the structure must resist. This includes lateral wind forces on the walls and uplift forces on the roof. Lastly, seismic loads in earthquake-prone regions. Seismic loads are critical. The design should consider how the structure will respond to ground motion during an earthquake. This may involve special bracing and fastening techniques to enhance the structure earthquake resistance. The next question is differentiate beam, columns, and girders. Firstly, we go to the definition. A beam is a solid with one dimension that is much larger than other two. Beams are designed to bend and redistribute weight throughout a building's foundation. For column is a vertical structure that supports a load similar to the legs of a table. Columns are used to support beams and arches and transfer the weight of the structure above down to the foundation. And a girder is a large horizontal beam that acts as the primary support for structure. Girders are designed to support other beams and provide the primary horizontal support for a structure. Girders are often used in bridge to support the roadway above and the piers below. Next is the function of the beams, columns, and girders. Beams are designed to support transverse loads and to carry the loads to support such as columns or walls. The floor on the columns on the floors above are supported by columns. The columns of the bottom floor must be larger enough to bear the accumulative weight of each floor above it. And girders are typically used in larger structures to support beams, and in some cases they may span longer distance than typical beams. They are designed to support concentrated loads. For the position, beams are typically placed horizontally and are supported at each end. For the columns, should be positioned uniformly on all floors for the most efficient supported. The stability of the lower set of columns would be improved. Lastly, the position of each girders is tightly connected to the axis geometry, placement and girder reference. In addition, for the load resistance, these beams support the load by resisting being bent under the load's pressure. Beams resist this force in lateral way as the force is applied to the axis. Secondly, columns resist axial compression forces. Lastly, girders resist bending, shear, and torsional forces. Lastly is material that we use. For the beams, the material that we use is steel, concrete, reinforced concrete, timber, and wood. For the columns, the materials that we use is steel, concrete, reinforced concrete, and masonry. Lastly, for the girders, the materials that we use is steel and reinforced concrete. That's all from me, and now I will pass to my friend to explain the question number 4. Thank you.
Assalamualaikum and hi everyone. My name is RES457 QARIHAH BINTI AHMAD HAZRY. So in this video, I will present for question 4, which is differentiate damp-proof membrane DPM and damp-proof course DPC for floor. Okay, what is the difference between damp-proof membrane DPM and damp-proof course DPC? Firstly, we start with the purpose. Okay, for the damp-proof membrane DPM, the purpose of it is to prevent the upward movement of dampness or moisture infiltration through floors, especially from the underlying ground. Meanwhile, for the damp-proof course DPC, it is to prevent rising damp from moving upward through walls or structures. And then we move to the types. The difference is for damp-proof membrane DPM, the type of it is polyethylene DPM, and then we have polypropylene DPM, and then we have PVC DPM, and last but not least is bitumen-based DPM. Meanwhile, for the damp-proof course DPC, the type of it has firstly lead, and then we have copper, bitumen, mastic, asphalt, polythene, slates, bricks, and last but not least is materials for mortar. Then we move to the next one. Okay, the next is for placement factor. Okay, for the DPM, it is spread out horizontally over the whole floor area under screeds or concrete slabs. But for damp-proof course DPC, it placed horizontally, which occasionally vertically within the wall and commonly positioned at least 150 mm above ground level. And then we move to the applications. The difference between damp-proof membrane DPM and damp-proof course DPC is for the damp-proof membrane DPM, it is commonly used on ground floors that are in direct contact with the ground occurs. But for damp-proof course DPC, it is found at the base of the walls, particularly in conjunction with floors where it is to protect the wall structure. Okay, last but not least, we move to the key feature. Okay, the difference between dam-proof membrane DPM and dam-proof COS DPC is dam-proof membrane DPM functions as a continuous barrier to moisture under the floor. Meanwhile, for the dam-proof COS DPC, it is to preventing moisture from rising into walls, which to protect plaster and finishes. Then for this slide, I provide the picture of the placement for the dam-proof membrane DPM and dam-proof COS DPC, which as you guys can see from the picture, I put the red circle to show where actually the DPM and DPC placement. Okay, so as I explained early, the difference between the dam-proof membrane DPM and dam-proof COS DPC, it shows that they have their own rules and difference between them. But to put a conclusion, the combination of DPM and DPC ensures a comprehensive dam-proofing for floors and walls, which contributing to a dry, durable, and healthy building environment. They serve distinct but complementary roles in controlling moisture ingress and rising dam. So that is all from me. Thank you for listening.